Alright guys, so now we're going to be talking about systems of equations instead of systems of inequalities. Alright, so an equation is something that has an equal sign. It usually has things on both sides, but sometimes it can equal 0. So we're going to start off with an example just to double check what is the solution. Okay, it makes the equation true. And I'll explain what true means in just a minute. So let's say we start off with this equation. So we have y equals negative 1/2 x plus 3. And we want to know what is the solution for that. Okay, so let's just pick a point, any point. Let's say 2, 3. We're going to plug it in and see if it's a solution. So my x is 2, my y is 3. So y is 3, negative 1/2 x is 2 plus 3. So now I need to simplify this right side. So negative times a positive is negative, so my sign's going to stay the same. Half of 2 is 1. Okay, another way to do that is 1/2 times 2 is 1 times 2, 1 times 2, which reduces to 1. But the negative stays, plus 3. So 3 stays the same. Negative 1 plus 3 is positive 2. That is not true. So this is not a solution. Okay, what about the point 4, 1? Let's try that. X and y. Y is 1. Oh, sorry, x. We're plugging in 4. Okay, this is multiplying because there's no sign between them. So negative times a positive is negative. Half of 4 is 2 plus 3. Again, if this part confused you, half times 4 over 1. We multiply the tops, multiply the bottoms. 4 divided by 2 is 2. Alright, negative 2 plus 3, opposite sign, so I subtract to get 1, keep the sign of the bigger number. Hey, 1 equals 1. That is a true statement. Therefore, this is a solution. Okay, so when we're dealing with systems of equations, we're going to have two equations, and we need a point that makes both of them true. Okay, so systems means we have two or more equations. And the solution makes both true. Not just one, but both. Okay, so when we're looking to do this via graphing, okay, so we're going to make sure that this is the graphing method. All we have to do is look for where do they intersect. Okay, so let's say we have two equations. So we have y equals 4x minus 5 and y equals negative 2/3 x plus 9. Let's make sure we have 9. 1, 2, 3, 5, 6, 7, 8, 9. Okay. That one starts way up here. Alright. So let's go ahead and do this one in orange. So this starts at negative 5 on the y-axis, so negative 1, 2, 3, 4, 5, and it goes up 4, right 1. So up 4, right 1, up 4, right 1. Up 4, right 1. And it keeps going. This is equal, so it's solid because every point on this line is a solution. Okay. And hopefully these two intersect. So now we're going to look at this one. Start at positive 9 way up here. And we go down to right 3. So down to right 3. Hey, that's a point. Down to right 3. Down to right 3. Okay, so we can clearly see that this point right there is our point of intersection, which means that is a point on both lines. Therefore, it is a solution. So our solution, we need to write in terms of x and then y. So my x is 1, 2, 3. My y is 1, 2, 3, 4, 5, 6, 7. So I can check it by plugging it in like we did before, but it should make both of them true. Now, I want to go over 2 other cases. There are technically 3 cases when you have 2 lines. So first case, they never intersect, which means our lines are parallel. Okay, their slopes are the same. Okay. Case number 2, they always intersect. Meaning they are the exact same line. So if I have this line here, and I graph another one, and they're right on top of each other, it's the same line, and they have infinite solutions. Okay, these have no solutions. Oop. And then the case above is case number 3, and they intersect once. Okay, so we've got a line here, and a line here. They intersect right there. So this has one solution, x, y. Remember, before you graph any line, make sure it's in y equals mx plus b. Slope-intercept form. The m is always going to be your slope. The number without the x will always be your y-intercept.